Yes, we have a question here. X and Y are in low nibble of 30 hex and high nibble of 30 hex respectively. Do X is equal to X plus Y operation and check the result for carry. As you understand, actually X and Y 4-bit numbers. So what can you think about the carry? Because the addition operation actually 4-bit and 4-bit. What is your carry? It is carry flag or not? First of all, we have to define it. If your operation 8-bit operation, so your flag can be carry flag can be affected. But if your addition operation only 4-bit operation, carry flag is not affected from this operation, we can understand from 4th bit of the register. Okay, it is important for this question. And if the carry is 1 from this operation, port 0.0 should be 1. Otherwise, port 0.0 should be 0. Assume that 30 hex is equal to F5 hex and also 30 hex has 55 hex for the solution. Okay, we will do this question for this lecture. Let's start to solve this question. We have some routine for all question for all assembly programming language. Origin 00 hex, sjump x, and we will start from the X label here. Okay, what will we do first for this question? We know that, friends, we know that all ports has FFX value after the reset or starting the program. Okay, but this question will use the port 0. It means first of all we have to clear port 0. Okay, so move port 0 00 hex. What about next? We have a number in the data memory in 30 hex address, but for this question we assume some values. Okay, so we have to send these values to the related register. So move 30 hex should have 5 F5 hex. Okay, for the assuming one, and then we can start to the program. What will we do now? First of all, we have to get the value. We can take the value to the accumulator as like that, and we know that the first nibble or low nibble of this number is x. Okay, we have to get x value. So how can we do it? We can do masking operation by using the AND operator. Okay, logic operator. A and L. A, we have to use 0f, not 00 block, because we want to masking only high part of the number. So we have to use 0fx. Okay, now we know that in A we have x value, and then maybe we have to store this value to the some memory cell. Maybe we can use move 20 hex A. Now we know that in here we have X value. Then we have to get the second value, which is Y, and we know that Y is high part of the number. Okay, we can continue. Now we have to get the second value from the 30 hex. First of all, we should get the value to the A, 30 hex, and then we have the second number in A, but Y value is only high nibble of this number. Okay, so again we have to masking operation again here, but which number? For the high part, we have to use 0f0. Now in A we have Y value, but not exactly Y value because Y is only 4 nibble, 4 bits. So we have to swap this value in A. Okay, we have to do this. So we should use swap A. Now we have Y value in here. We have Y, but it is in high nibble. Swap A. Now we get the Y value for this question. Now we know that Y value is in A register and X value is in 20 hex address. So we can add these two values by using add command. Add commands, yes. Add A with 20 hex. What is this equivalence? X plus Y. Okay, what about the carry now? The result in A register. If we carry, we should be 1 to the port 0.0, otherwise port 0.0 should be 0. Okay, to do this operation, we have to use conditional branching commands. But which one? The result in A, right? In A, and we know that maybe we can write it like that. One, two, three, four, five, six, 7, and 8. Yes, only we do 4 bits addition operation here, and if we have a carry, this carry should be in this bit, right? So we have to control, we have to check fourth bit of the accumulator. But which command we will use here? For the bit operation, we know that we have JC command, jump if carry. We have JNC command, jump if not carry. We have jump bit command, jump if not bit command, and jump if bit and clear. We can use jump if bit, accumulator, fourth bit. And if we have any carry, port 0.0 should be 1. So we can say the carry to the label. And if this condition is not satisfied, the program will continue to work with the next line or next command. In here, what is mean for us? Actually, otherwise condition is satisfied. It means carry is not 1 and port 0.0 should be 0. So in here we can say clear port 0.0. And then we have to tend this program to the finish, because this operation will be done only one time. We can use sjump finish. And then we have two labels, but in the program we don't have yet. We can define this label. If you have carry, you will do this operation. Port 0.0 should be 1. So set bit port 0.0. Okay. And then all operation is done, but yet we don't have finished. In here, finish label is here. And as you know, if you do this operation only one time, you have to use endless loop. Okay, sjump finish, and then we can write end comment. First of all, we have to define manually what is the number for us. X number actually 5 for this question now, and Y value is F for us, right? Maybe we can use calculator to do this. We have in hexadecimal number system, we will add F plus 5. What is the result? 14 hex. Okay, so the low nibble will be 4 and high nibble will be 1. It means if your high nibble is 1, we have a carry for this question. Okay, and we know this for our question. This value is in 4th bit of the accumulator. Okay, yes, let's compile this question now. Yes, we have two error here. Where is the error? Yes, the first error is in this line, clear port 0.0. And what about the other? The other is in this line, set bit port 0.0. For this error, we have to do some operation. Actually, we know this. Port means peripheral unit for our microcontroller. Okay, but in here we didn't define the microcontroller header file. Before the origin, you have to click right on your mouse and insert include rec 8253.hex file. Okay. After this defining, your microcontroller should know what is your microcontroller, what it has. Okay. When you compile this program now, we don't have any error, any warning, and hex file is created in this address. So we will do this operation. We will check this operation in the simulator on this program. Yes, we will continue, compile this program, and start debug session simulator on this program. As you see, we are in this line because, as you know, this is a directive, not a command. So the program will start at the first command. Okay, first command for us sjump x. In here we can work this program step by step, step one line. We are in this here, but this question we will use port 0, right? And port 0 peripheral unit for us. We can add the related peripheral unit by using this icon, as you see. And in here we have a IO ports, and we will use port 0. And as you see, now we have port 0 here. And we know that from the lecture, all ports have FFX value after the reset or first starting. In this line, we will clear this port. You can see now port 0 is cleared. And then the related number is loaded to the 30 hex address. You can see in here 30 hex address has F5 hex value now. And this value is loaded to the accumulator. You can see here accumulator value has F5x value now, and we will continue to the work. A and L means for the high nibble we do a masking operation because we want to get X value. And we know this, the low nibble or the number is X. Okay, now we have X value here, and this value is loaded to the 20 hex, and then we should get the second value, Y value. So we will do another masking operation. Now we have Y value, but we know this Y in high nibble of the A. We want to get to the low nibble. We will use swap command. Now we have the Y value in A. We can do this operation now. Y value is in A and X value is in 20 hex address. If you add these two numbers, as you see, the result will be 14 hex. Okay, so we have a carry here. In here we have a conditional branching command. If your carry is 1, if your this bit is 1, condition is satisfied and your program will go to the carry. Okay, and you can also see the number of the related memory by using this function. And you can see here ACC.4 is 1. Yes, now you can see your program tends to the carry label, as you see, and in here we will do this operation set bit port 0.0. Where is this? Port 0.0, this memory cell. Yes, and then we have endless loop. Your program will finish. If your carry is 1, your program will continue to the work at this line. Yes, if your carry is 1, your program will continue to the work at this line because this condition is not satisfied. Okay, so we can say the new label here, if this condition is satisfied, it means you have no carry, right? And if you have carry, your program will continue at this line. So we have to set port 0.0. But if you don't have carry, your program will go to the no carry label, so we can change the label as like that, and in here we have to clear port 0.0. Okay, just this. Let's do this. Build again, 0 warning, and we are in debug session. Yes, let's continue. Port 0, we get the values, and we are in conditional branching command. Now we expect this program should go to this line, right? Because we have a carry for this operation. Let's check it. As you see, your program will go to the next line, and then port 0 is set, and as jump finish, your program will be finished. Okay. Yes. We have another question for you. Without using the accumulator for checking the carry value, how can we do the same operation? Without checking the accumulator 4th bit, how can we do the same operation in this line? Yes, we have a lecture notes here. Program status word has another memory cell as like that. The first one, please remember, parity bits, reserved, overflow, bank selecting bits, reserved, and AC. What is AC means? If the 4th bit operation, as you see, auxiliary carry, actually it's mean, when a carry occurs from the low 4 bit to high 4 bit, this flag will be set. Okay, we can use AC bit for the same operation. So in here we can use PSW point 6, because as you see, AC is 6th bit of the PSW, and also we know this PSW can be bit addressable, so we can use PSW.6, but we have to compile program again. If you do any modification in your program, you have to compile again. Okay. Evet, we have no error and no warning, and we can go debug again. Until this line, actually we have the same operation, so we can insert a breakpoint here, and we can run the program to the related cursor line. And the result now, as you see, A is 14 hex. And also, you can see PSW in here. Look at here. PSW is 40 hex. And it's mean for us, AC flag is set, as you see. Actually, we use this flag. And we expect from the program, we have a carry, so our program will continue from this line. And set bit and finished. We can do the same operation by using the 6th bit of the PSW. Yes. What about the other numbers? If your number will 55 hex, what will be happen now? We can do the same operation in this program. Yes, in here we will change the value. And what about the others? We don't have any modification in this program also, so we have to compile, and we can load this debug session. Now what is the result? We know this, the low nibble x and high nibble y. What is the result from the addition of to this number with each other? 5 plus 5, it means in decimal number system 10. 10 means in hexadecimal number system A, 0A. So your result should be 0A hex. Okay, we can continue to the program step by step. Port 0 is cleared and 55 hex is loaded to the 30 hex address as you see here, and the related number is loaded to the accumulator, and the high part is masked here, and the X number is loaded to the 20 hex address. Then number is obtained to the accumulator, and high nibble is masked, and high nibble is inverted to the low nibble, and then we will do the addition operation, and we expect from this addition A should be 0A hex. Okay, maybe we can do, yes, we are in hexadecimal number system. 5 plus 5, it will be A. Okay, yes, as you see, the new value of the accumulator 0A hex. It is mean that also we don't have carry now. Okay, so jump if not bit PSW.6. If the AC value is equal to 0, this condition is satisfied, so we'll go to the no carry label. Okay, we have already no carry, so your program will tend to the no carry label and clear port 0.0. Your program will be finished. Yes, we can modify this program again. If I want to do this operation, how can we do it? Yes, we'll use the same number, but we will do subtraction operation. So until this line, the same operation will be done. But now, if you do x minus y operation, first of all, you have to get the x value to the a. Okay, so until this line, we know this y value is in a. We can transfer this value to the 10 hex, for example, and then we can get the first value x. Maybe we can write here y again, and we can get the x value from 20 hex address. In here we have x, and as you know, if you do subtraction operation, first of all you have to clear carry flag. Why? Because now we will do x minus y. What is the x minus y value for us? X is equal to 5, right? And y is equal to 5 for now. So it means it will be 0. But if I have 0f 5x, assuming 1, okay, what will be happen now? X value is equal to 5 and y value is equal to f. 5 minus f. What will be happen now? We can do the same operation here. 5 minus f. It means this number, but we have 8-bit operation in here. So your result should be f6. Okay. and your carry flag should affect the same operation. Okay, so we have to clear C, and now we can do sub A. Where is the Y value? 10 hex, and then we can use the check now for this question, jump if carry, or we have already no carry label, we can use jump if not carry. Okay, but we don't use anymore AC flag because the affected flag is carry flag. It's mean PSW point 7. But we know this conditional branching command has used already carry flag. We don't need to write this part. If the carry is not, it means carry is 0. Your program will go to the no carry flag, no carry label. And if you have, then port 0.0 should be 1. Let me compile it, and then we'll go to the debug session. Let's do this operation. Yes, until now we have the same operation, and now the subtraction result will be, we know before, we'll do now again, 5 minus f, sorry, 5 minus f. We are in decimal system. 5 minus f. It means f6x. Okay, a will be f6 now. And carry flag also here, carry flag also will be set. As you see, a is equal to f6 and carry flag is set. Okay, so we can use the carry conditional branching. We have carry, so your program will set to the port 0.0, and then you will finish. Maybe we can do the same operation, 55x in here again, 55x, compile the program and debug session. Let's continue until the conditional branching. 5 minus 5, it's mean a is equal to 0, as you see, and we don't have carry, as you see. Your program will go to the no carry line. Yes, clear port 0.0 and program will be finished.